Hi guys. So the lecture that I attended was the one on my bad. Molecular biomechanics and mechanobiology. Now, this lecture was given on the 24th of November, and it was given by Dr. Chang Zhu. So there were several important things that I learned at this lecture. So one of the first things that Dr. Zhu talked about was mechanobiology at the molecular scale. And he talked about the different devices that are essential to mechanobiology. So he talked about a mechanopresenter, which is a molecule that presents information to the mechanoreceptor, which is the next thing. And so a mechanopresenter presents information to the mechanoreceptor upon changes in its mechanical environment. And then a mechanoreceptor is a receptor that receives mechanical cues via an engaged ligand. And then next we have a mechanotransmitter. And what that does is it's a structural molecule that transmits the mechanically encoded information over distance. And then we also have a mechanosensor, which is a molecule that converts the mechanical signals to chemical signals. And then we also have a mechanoresponder, which is a molecule that changes its mechanical behavior in response to intracellular signals. So these are the fundamental devices, I guess you could say. They're the fundamental parts of mechanobiology at a molecular scale. And so what Dr. Zhu was really talking about was he was talking about having bonds under force. So he gave an example of how if you have like a force, and suppose this is a petri dish, as your force, which goes to the molecules in the petri dish, moves up and down, your amount of your bond lifetime will go from a very short amount up to a very large amount. So he was talking about how as well the binding of different molecules such as the ADAMT13 will change based on how the VWF flow happens, which essentially changes the amount of force that's going on in this petri dish. So as the binding changes, the adhesion frequency will also change, and then the lifetime of the force, or the lifetime of the bond, will change as the force changes. So what he found was that if this is our lifetime of the bond, and then this is the amount of force we put on it, as the amount of force increased at a almost exponential rate, the lifetime of a bond would decrease. And so this is obviously very important because it tells us how much bond to place, or how much force to place in order for a certain bond to remain for a certain amount of time. So as well, one of his conclusions was that the VWF flow is a mechanopresenter because it because it changes its conformation, to present different binding sites to a different domain of the ADAMTS13 when it's exposed to, how about this, two different binding site to a different domain of this when it's exposed to different types of flow shear stress. Now, I thought this was really cool because it really explores how physics can apply to biological systems. For example, one thing that he talked about was how the ADAMTS13 can cleave ultra-large VWFs and reduce their adhesive activity. And then for patients with certain kinds of diseases, this cleavage leads to platelet aggression. Or sorry, not aggression, aggregation. That's what I meant to say. As well as formation of microthrombi, which of course, or thrombi, which of course has important biological effects on the human body. And he also talked about how, it, as well as in mechanics, in that same way, the same principles will affect biological systems. So it's not just in mechanics that we use principles such as A of F is equal to F over M, which talks about the relationship between force and motion. And then, of course, X of F is equal to F over K, which talks about how force causes deformations. And so you can take these equations and model them into into biological use. For example, we can say that R plus L is equal to B, and that relates the molecular interactions from reaction kinetics to the mass action law, depending on how your shear stress is. So those are just some of the things, or not shear stress, my bad, the kinetic off and on rate is. So those are just some of the things that he talked about that I thought were very useful, and I thought overall it was a really interesting lecture that really exposed physics in a biological way, which had not really been done for me before. So I am very grateful to him for doing so. So thank you.